morning. First of all, thank you, organization, for having me here. It's really exciting to stand on stage. I haven't done a talk in about a year and a half. I joined Datadog about a half a year ago. So it might be a little rusty, so bear with me. It's also a little early. So I'm Wouter de Bie, which is Dutch. It's a little bit hard to pronounce for some people, but you can butcher my name later if you want to. I'm an engineering director at Datadog and mostly focused on data engineering. So I'm going to do this talk, and I've kind of going to speak for all of you when doing this talk by asking a few questions that you might want to ask. So Wouter, what are you going to talk about in the next 40 minutes? Just have my coffee, breakfast, dying to listen to your talk. So tell me more. So what I'm going to talk about is how I've built data engineering teams over the years. We'll talk a little bit about data engineering itself, some common patterns that I've seen while building these teams. I'll want to talk a little bit about horizontal and vertical teams, and I'll explain what that is, and how to get high-performing teams. So this talk is not going to be technical. There are lots of technical talks this conference, but figured it might be fun to talk a little bit about something else. So, all right, Wouter, nice to meet you. But before you start, who are you and why are you? Talk to us. Well, who am I? So I'm Wouter de Bie, engineering director at Datadog, and as Pete mentioned, formerly engineering director at Spotify. I'm Dutch. I live in Brooklyn, New York, until next week. So, great. We're here to talk about data, not about where you're moving, but still, probably a few of you wonder where I'm actually going. So from next week, I'll be living in New Orleans, Louisiana, which is probably one of my favorite cities in the world, and I'm actually very, very blessed to be able to move there. It's the internet age. Datadog lets me work remotely, travel back and forth to New York and to Paris once in a while. But we have Mardi Gras, which is pretty awesome. All right, let's go to business. I've been at a few companies before. What have you that have gone through hypergrowth? So what did that really mean? So yeah, Spotify went through hypergrowth. When I started in 2011, there were 250 people. Global engineering team was about 70. When I left, there were 5,500 people. And I left in 2018. So over the course of 7 years, we had gone from 250 to 5,500. Kind of a fast growth. Datadog has been growing, doubled every year in terms of employees. We're currently at about 1,500 people. So that's what hypergrowth means to me. But Wouter, apart from employee growth, did you have any scalability challenges? Yeah, scale is a big challenge. So if we look at Datadog is a company that focuses on observability as a service. We ingest metrics, traces, and logs from our customers. We are in multiple clouds, and we do billions of points a day that we ingest from all of our customers. We process that, we visualize that, we create alerts, we trigger things. So that's pretty massive scale at the moment. Spotify had the same thing. Some music streaming servers, probably most of you know Spotify. Most of the data that we collected was about playback. So you'd play a song, we'd record what you were playing, by which artist, and do all sorts of cool stuff with that, apart from reporting and making sure that artists get paid. We would do recommendations, all sorts of product features. We had hundreds of millions of plays a day, and hundreds of millions of active users on a monthly basis. So that, to me, was scale. And obviously, there are companies that are bigger, that do large scale, but still, there's quite a lot of there were a lot of challenges in that. But today, we're here to talk about data engineering. So, I might hear you think, so Wouter, you did a bunch of data engineering. Tell me about that. What did you do? I first wanted to talk about the definition of data engineering, because there seems to be a bunch of definitions out there. I just Googled data engineering definition, and these were the first 3 hits that I got. So looking at a blog post on TechTarget, it defines data engineering. A data engineer is a worker whose primary job responsibilities involve preparing data for analytical or operational uses. O'Reilly mentions build and maintain organizational data pipeline systems, clean and wrangle data, I like that term, into a usable state. And then DataCamp had ensure clean, reliable, and performative access to data and databases. I want to throw in my own definition here because one of the things that I really missed is sort of the scale. When we talk about data engineering at Datadog, we're talking about the large volumes of data. It's often batch, not per se, but it's really the volume that matters in this case, which I'll talk later about. Like it requires different skills. So data engineering takes care of storing and processing large volumes of data coming from different sources and making it available for downstream applications. So it could be machine learning, analytics, we could use it in product features, etc. But Wouter, these data engineers, they process data and such, but who runs those systems that they use? So at Datadog, and we did the same thing at Spotify, we made a differentiation between data engineering and data infrastructure engineering. So I'm going to throw in another definition here. To me, data infrastructure engineering that builds, maintains, and operates the systems that enable data engineers to do their work. So if you look at the different skills required, on one hand, we have data engineering, that those are people that write Spark, MapReduce, Apache Beam, data flow, pipelines, etc. The skills that are required are definitely understanding sort of data concepts, how to wrangle that data, like sorting, grouping, filtering, things like that, aggregating data. You see that often people who work as data engineers have to have an understanding of the domain that they're working with. So for example, at Datadog, the data engineering team is highly specialized in understanding how metrics work. How do you aggregate metrics in both space and time, for example? How do you optimize these processes, but really specific to the domain. At Spotify, I used to work with teams that were specialized in the domain of creators, so record labels and artists. They knew everything about that domain. Or being able to prepare data for further analysis or machine learning, etc. And data engineers often have to understand the scalability of data. Like how do you say that you go 10x in volume? How do we deal with that? How do we optimize our pipelines to be able to run this stuff? On the other hand, we have data infrastructure engineering. These people, the people on those teams, they operate the processing systems. They have an understanding of things like Yarn, Mesos, HDFS, like Hadoop as an ecosystem. These people often write tools to make life easier for data engineers. So Datadog, we use a system called Mortar. And Mortar enables us to schedule Spark jobs. Mostly Spark jobs. It uses Luigi under the hood, which is a dependency resolution and orchestration system that I actually wrote together with my team at Spotify back in the day. So these teams, they build, they don't only maintain and operate the systems that allow us to run these data jobs, but also write a bunch of software. And they understand the scalability of systems. They obviously have to think about what it means if the volume of data gets like 10 times as large, but they don't have to have that domain knowledge. They really have to understand systems. So you often see when hiring teams that on one hand data engineering is, I would say, a skill that hasn't been taught for that long. So you have people coming out of school nowadays understanding more about like big data processing, but it's kind of a relatively new field. While in data infrastructure engineering, there's more overlap with sort of regular backend engineering and distributed systems. But of course there's overlap. So, and I'll get into that more, but there is overlap. Still, yeah, people on the data infrastructure engineering side have to understand more of like what the data means than, say, a typical back-end engineer. So here you think, Wouter, you've been at a few companies. Are there any common patterns that you've observed while like building these teams? And yes, obviously. So what I've seen is that you could, like the evolution of data engineering at the companies that I've been at follows sort of a common path. Big data starts small often. So there is some interesting data somewhere. At Datadog, obviously this is data that comes from our customers. At Spotify, this was usage data from our users. At Spotify, this data was already used for creating reports that went to record labels, and based on that, artists would get paid. That was part of the business model. At Datadog, that data comes in because we actually have to visualize that. Our customers have to be able to query it, have to do things. But very early on in the stage of these companies, that data is already there. What I've seen is that it often starts, sort of the whole big data journey starts with a small team, and that one small team does a lot with the data. They do multiple things with it. And at the same time, this team operates the infrastructure that is there, does data engineering, and often performs analytics. So those are the only people that do that. Now, once things grow and the value of big data becomes apparent, the small team tends to be a bottleneck. So what happens is that small team starts splitting up into analytics, data engineering, data infrastructure engineering, sometimes other teams even. But you see like that growing. At Spotify, we went from a small, we called it business intelligence back in the day, business intelligence team that did everything, to analytics infrastructure, which later became data infrastructure, an analytics team, etc. At Datadog, where sort of at that point, we had a team, one team that did both data engineering and data infrastructure. Today we have two teams. Probably by the end of the year, we have 3 or 4 teams more focused on different aspects of data processing, data engineering. And then sort of the last step is that big data becomes part of day-to-day. So data engineering, rather than being a central team doing stuff, data engineering becomes more of a competence. So every part of the business will eventually have data engineers that like prepare data, that work with data day in, day out. Because every domain starts needing that. What we saw at Spotify was that the creator side of the house had data engineers really specifically focused on artists and labels. We had data engineers for machine learning, preparing data for machine learning. We had data engineers that would do product analysis or worked on the product side and prepare data for analytics. So if you look at Datadog's evolution, I kind of alluded to that already. There was a single team that focused on analytics, data engineering, and infrastructure, and single team split it into sort of data engineering and data infrastructure. These are currently the teams that are in my group. And currently we have that data infrastructure team. We have a data engineering team for historical metrics. What happens at Datadog is that we ingest data from, or we get data from our customers that goes into live systems for querying, but that data only stays there for about 17 hours because storing data in live systems and in memories is really, really expensive, and on SSDs for fast access. The use cases change after like these, say, 17 hours from sort of immediate access to data to like longer term graphing, for example, and longer term queries. So what we do at the same time is the data gets processed by Spark jobs. We run a bunch of ETL on that and do pre-aggregations or aggregations on the data and make it available to our query system. Our very smart query system is then able to load data from the live systems and from the historical files that we produce and can give results back to our customers. So this is all happens seamlessly, but underwater there's a bunch of Spark jobs that are running. So that's what this team does. We have an internal analytics group. They do all sorts of cool cool analysis on the data that we have. We have a team that's called revenue engineering that basically looks at usage and eventually bills our customers based on that usage. And then we have data science using the data as well. Compare that to Spotify's evolution. Same thing. We started off with a team focused on analytics, data engineering, and infrastructure. That was the team that I joined back in 2011. There was really 3 engineers and 3 analysts, and we pretty much did everything. We ran Hadoop. We created data pipelines. Back in the day, this was Python MapReduce. Don't ever do that. I had at least 3 Excel sheets open on my desktop every day to help out with some analytics. But then, as I mentioned, that became a bottleneck, that team, because there was so much. There were so many questions from all over the business. It started off with analytical questions, but more and more people wanted to have product features. We had top lists, for example, and that meant that led to splitting this team up into sort of analytics and data infrastructure. And within data infrastructure, we even did a lot of data engineering as well. Currently, at Spotify, there's a data infrastructure organization. When I left a year and a half ago, there was about 50 people. I think they might be a little bit bigger right now. And data engineering is a competence. There isn't a single centralized data engineering team anymore, but that happens all over the place. Analytics has become a competence. So before, so analytics was a single team for quite a while, but also that became a bottleneck. So product analytics is very different than marketing analytics, than financial analytics, etc. So you saw these people specializing and then moving into these parts of the business. And then data science is a competence as well there. So we have data scientists all over the place because you have data scientists focusing on recommendations, you have data scientists focusing on stuff for artists, etc. And I hear you think, but Wouter, when data engineering becomes a competence, then that can be found in many teams, and how do we ensure that knowledge is shared? And I think this is one of the bigger problems that I've seen organizationally. How do you keep people together and feel that they belong to sort of a group of data engineers or data science or analytics while they're working on different things? How do you make sure that everybody uses the same tools, that everybody uses the same processes? So there are 2 things that I've done in the past. One was called a data engineering guild. This is, Spotify had some interesting organizational structures, and Spotify had interesting organizational lingo. I don't know how many of you are sort of have seen some of Spotify's little videos about how they're organized, but Spotify had a matrix organization, which meant that management and delivery was separated. We had squads and chapters where people were working on, which also caused the problem of people had to belong together or had to come together to share knowledge. And the organizational structure that they invented was called the guild. And within a guild, no actual work happened, but people would come together to share knowledge about how they would work, what kind of tools they would use, and even sometimes set standards. At Datadog, the same thing happens. So we have data engineers in revenue engineering, we have it in the team data engineering metrics, we have it in analytics, etc. And twice a week, engineers come together and talk about stuff that either needs to be done or new technologies that have emerged, new ways of working, new paradigms are being discussed. At Datadog, there is a bit more focus on the guild actually doing things together, which I kind of like. It's fun. Get to work with people from different sides of the company. So we work on deprecating old libraries, for example. In our case, we have to move from Python 2 to Python 3 because Python 2 is being deprecated. That's a nice thing to work on with the guild because everybody has to do that. So you have people from that guild driving that in different teams. But it's a kind of a informal group, and it's very self-organized. A second thing that I did at Spotify was started Data University. This was a curriculum that was focused on teaching data engineering skills. And it was used for onboarding, but also for training engineers in sort of the art of data engineering. So you had, this was mostly back-end engineers, I would say, but also a few front-end people here and there that were interested in data engineering. So like I would just want to add this to my toolbox, to my skill set. So like me and a few colleagues wrote a curriculum, ran that about every quarter, started off with 10 people in the room, and after about a year, this became fairly large. We had like 50 or 60 people taking a course for a week, going from like how do you operate, not super in-depth, but like what does MapReduce mean, for example? How do we, because it's kind of still the foundation for many of those frameworks out there, to like how do you get your data from one point to another point? How do you process data? How do you expose that? How do you make it available for downstream teams, for downstream systems, etc.? So that was I think it was a great tool because that really sort of accelerated data engineering as a competence throughout these systems, and people don't have to be formally trained, whatever that means, in data engineering. So here you think, right? So I need a bunch of teams, but how do you then decide how to divide my engineers? Again, any tips? So if you split teams, then obviously you need to split them across something. So I'd like to talk a little bit about horizontal versus vertical teams. I use this a lot when thinking about team structures because there are so many dimensions that you can slice and dice a team around when you're going through a split, when teams become too big and you need to split them out. So what I mean with horizontal and vertical is that, to me, vertical teams have a narrow focus on often one group of constituents, and I have a little example later, or like a single domain. So for example, in Datadog we have historical metrics. That's a pretty specific domain because at Datadog we have metrics, APM, and logs as sort of the three pillars of our product. So the metrics is one sort of vertical. It's a narrow thing. Revenue engineering is a narrow vertical because it is like being able to bill our customers. That's really the use case. In Spotify, we had recommendations. That was a vertical. These are recommendations for our customers. It's not a very broad spectrum of things. Then we have horizontal teams, and they have a wide focus on often just providing data to many other downstream teams. So they don't really care about the domain, any particular domain. It's really making sure that other teams are able to use the data. They have access to data in a way that works for them. And infrastructure, by definition, is horizontal. So you have, it supports the rest of your teams. So as an example here, you can see that analytics is often sort of a horizontal. Actually, analytics can be both horizontal and vertical, depending on how your organization works. But say product analytics would be a vertical team or part of the organization. Revenue is vertical. Metrics is vertical for Datadog. Machine learning, data science can be vertical. And then when it comes to horizontal, we can often have you can have a team that works on what I like to call foundational data. This is data that can be used by all these other teams. And again, that team or organization, part of the organization, doesn't really care about the domain of that data. At Spotify, we had a organization that I was part of at the end of my stint there. It was called just Data, which was kind of a cool name. And we made sure that the data that really mattered for the business, so we call it business critical data, was owned by that team. But that business critical data was used for finance, it was used for ads, it was used for ML, etc. And then underneath all of that is supported by data infrastructure. Data infrastructure makes sure that these teams can do whatever they need to do. So here you think, see, Wouter, but now I have all these teams being autonomous and all, they can do whatever they need to do, but they're building the same thing over and over again. Like this team uses this framework, that team uses that framework. Team A builds a scheduler, team B builds a scheduler. Any thoughts about that? Yes, I do. Because this is where infrastructure comes into play. This is like the part where infrastructure should shine. And how I tend to look at infrastructure in general, I've tried to sort of express that here in this diagram, is where if you look at how data often flows, comes in through some front end. At Datadog, that's most of the data comes in through agents that are installed on hosts, but it could be through other things. At Spotify, this was through Spotify clients in your mobile, on your desktop, a web player, etc. So data comes in through the front end, then often goes to backend service. Backend stuff happens there. Then that ends up in something that does data. I tend to avoid the term data lake, but that's often what people refer to. So that's where data pipelines happen, and then that data is often used for analytics and data science. And you could even, and this, I guess I forgot that, but you could even draw an arrow back to either back end or front end, because that data can be used in a product. But to be able for all these teams to move fast and focus on what they actually need to do, you have to have great infrastructure. So what we often see, what I've often seen, is that on the client, there's client infrastructure. Some team helps client teams build their things. They help out with frameworks. They set what frameworks are used, or they bless frameworks to be used. They make sure that, say, mobile clients can be built, that there's CI/CD for those kind of things. The same on the back-end infrastructure side. Companies that I've seen move fast often have like a standardized back-end in place. So they use a specific technology to build, deploy, and run back-end services. At Spotify, we used a lot of Java in the back-end. They had a system called Apollo that if you would start an Apollo project, you would get monitoring and alerting and service discovery, service connections for free, and that like caused people, like made people to use that backend technology rather than like deploying their own stuff. At Datadog, we pretty much standardize on Go for our backend applications. There's a lot of infrastructure and tooling around making sure that you can build and deploy your Go projects. And then data infrastructure, the same thing. So at Spotify, we standardized on Luigi for a while. At Datadog, we do a very similar thing. Some companies go for Airflow, but yeah, it's really making sure that everybody kind of uses the same thing, and these teams don't have to do everything over and over again. And the same goes for data science and analytics. Although I would say on the analytics side, it's a little different or a little harder because there's a whole bunch of tools that each have their own value. So, all right, Wouter. So I've grown my org, split my teams, hired the right folks. Now, how do they make sure that they perform? So I'd like to talk a little bit about sort of high-performing teams and what I've seen in the past, what works to make teams high-performing. I really subscribe to this. Autonomy, mastery, and purpose. Autonomy is like our desire to be self-directed, and it increases engagement over compliance. Mastery is the urge to get better skills, and purpose is the desire to do something that has meaning and is important. And if you make sure that these teams, that the people on these teams sort of subscribe to this, I've seen people, like the teams that really embody this, perform the best. In certain cases, there's sort of a tendency to add a lot of process to teams. That can help, definitely can help, but the essence is that if a team or an individual feels that they can make autonomous decisions, if they master what they do and you give them challenges to really do what they can do, and you give them purpose, then things tend to run much smoother. So some of you might have seen this, say like, that makes sense. I see you read Drive by Daniel H. Pink, which I did. It was a great book. If you haven't read it, would definitely recommend it. But how do I then make my teams value autonomy, mastery, and purpose? You can't just hand them a book and say, do this, right? So what I've seen is hiring is really, really key. At Datadog, we have a specialized interview process for both data engineering and data infra. We make a difference there. We ask different questions. Don't sort of throw it all on one pile and have a similar interview for everything. For both Datadog and Spotify, there was a great focus on skill, but also on culture. Unfortunately, I've had to reject candidates that just didn't fit the culture, and because if you over time encounter cultural issues and like people just don't fit sort of how you run a company, then those mistakes can lead to longer issues. If you have a technical problem, you can often solve it. People are a little bit more difficult. So that's why, like in both these companies, there's like a big focus on culture. And enthusiasm for the product that you have is really, really important. That's what really struck me starting at Datadog, is that everybody is so enthusiastic about what we do and the product that we have. We all use it on a day-to-day basis, so we dog food, and the pun is very much intended there. We all use Datadog on a day-to-day basis, which is great, because we also get to help improve the product. We find issues with it, and then we can help out, make it better. But everybody's really, really enthusiastic about the product, really enthusiastic about where the company is going, and that really, really helps when building teams. So some of you I hear think, all right, man, I've learned something, feeling the coffee. Can we wrap this up? Let's wrap this up. So. Just want to hope that you walk out of this room with a few takeaways. I think one important thing for me, at least, having gone through my journey working with data engineering and data infrastructure teams, is that data engineering isn't data infrastructure. So hopefully think a little bit about that going forward. Teams and organizations evolve, and that's fine. Not having a plan is sometimes okay. Just let things happen, and you'll end up but with a little bit of thought, you'll end up in a place that works for you. For me, the horizontal and vertical thinking has helped a lot to be able to make decisions on how do we split teams, how do we grow the organization, where do we invest, things like that. It's really important to build solid infrastructure. Make sure that your teams can focus on what they are requested to do, and not doing things over and over again. And as I just mentioned, like hiring is key. So lastly, just wanted to put a shameless plug in there. Most of you might have seen us. We're in the back there. We are hiring. So if you're looking for a fun challenge with a lot of scale and a lot of data with cool people, then please come and see us. We're doing some demos there as well. Rafael is doing an amazing job there. So come and see us at our booth. Thank you so much. If you have any questions, we'll take them at the...
So a lot of teams here are smaller than Datadog, and naturally the skills collapse probably sometimes into even one person, the data engineer, the data infrastructure engineer, et cetera. At what scale, like number of people in the team, do you think it starts to make sense to think about splitting?
That's a really good question. I tend to, veer on the side of 8 people is the max for a team. After 8 people, so we were actually in this exact situation at Datadog. One of the teams is about 12 people big. While our stand-ups in the morning used to take 5 to 10 minutes, we did quick updates. They take 25 minutes to half an hour, which means that it's not only the amount of people in a room, but also the scope of the team grows, and you see that there are multiple. I wouldn't say camps, because that sounds very sort of boxy, but we see that people check out because they haven't worked on a specific part of what the team does for a while, and yeah, they don't really engage. You kind of lose that sense of belonging with, I would say, more than 8 or 9 people. So I tend to say at about 8 people, we need to start splitting. As I said, this team is now 12 or 13 people big. Which I was a little late with thinking about the split, but yeah, hypergrowth.
And what about specifically between the data engineering team and the data infrastructure engineering team? Is there a size there where you think it starts to split apart those two functions?
Not really. I think when this team split, the data engineering and infra was one team. We split that up. The data infra team was only 3 people. We started with 3 people, while the rest was like 6 or 7 people on the engineering side. So it doesn't always have to be a 50-50 split. In this case, there were people that were more interested in infrastructure than in data engineering. The need for data engineering was at the time higher. There were more projects than on the infrastructure side. So yeah, it doesn't have to be a 50-50.
Great. Awesome. Thanks.
Hi. Thanks for the talk. Regarding autonomy, vertical and horizontal teams, so how do you handle situations where someone wants to build a new thing or use a new library, but then you have the horizontal teams regarding autonomy?
So if an individual wants to use a particular library?
Or a specific vertical team that, hey, we think that now we need to use this new thing and all the tooling provided by horizontal teams doesn't match.
Oh, so it's somebody on a say vertical team. The vertical team wants to use particular technology, and the horizontal team doesn't support that. Is that?
Yeah.
Okay. Yeah. So I think that's fine if there is an actual use case for that, right? If it's just because we're normally using Java, but I'm more into Erlang, and Erlang is better. You get sort of these holy wars. Then I think it's a bad idea to introduce new technology and introduce entropy in your environment. If it's for a good cause because there's functionality that's just not supported, then I think that team should really do that. In some cases, it just stays very local to that team because only that vertical team has the need for that technology. In other cases, other teams might take that on, and then through something like a guild, you might see that particular thing spread. I think it's a job of horizontal teams to pick up on that and say, well, there are 5 teams who are using this thing. This should actually be more of a horizontal function. So we're taking this on as part of our sort of internal product portfolio, whatever you call it, and start really supporting that for all these teams and making sure that it becomes more of a generic solution than a very specific one for each team that, sort of snowflake have different needs.
Okay, thanks.
Hi.
Hey.
I have a question about another dimension of the vision, about data and transactional, or data and backend, regarding the infrastructure engineers. Have to be splitted, the data infrastructure engineers and the backend infrastructure engineers, or not? Is the competence, is the same competence, same kind of team, same guild, same chapter? Because there are some specialties, exists a big overlap, but also there are some specific things that the data infrastructure engineers do and the backend do another thing.
Yeah.
And
I hear you. So the question is because there's overlap between backend and data infrastructure, how does that work? That's kind of the
exactly.
question? Yeah, okay. So that's absolutely true. Especially in the beginning of these teams, you see that a lot of sort of back-end engineers and tend to sort of gravitate towards data infrastructure. It's hey, I used to operate a Cassandra cluster. I know that type of stuff, which is cool. You have it's a big Java system. Now we have Hadoop, for example. Let me do that type of stuff. So you see there's a lot of overlap, and there's a lot of competence that can be used. But yeah, data infrastructure is far more towards back-end infrastructure. If you look at Datadog, for example, our back-end infrastructure is mostly Go. And data infrastructure, it's a little bit of a different thing because most of the systems are JVM based. We use Scala a lot instead of Go, so there's less overlap there. In terms of sort of paradigms and thinking, I guess it's similar. So you do see people transition from backend to data infrastructure or the other way around, and that's fine. Just use whatever you need, right? And make sure that people can move. But I personally think that operating data infrastructure is a little different than backend, often because the stack is very different.
Thank you. One more question about competence versus separate team. as you said that in Spotify, the data science, for instance, is more like competence, and currently you have separate teams.
Yeah.
I guess that you would like to split in the team between the activities rather than having different competence in the same team. But from my point of view, having, for instance, a person competent to do two different things and watch his knowledge probably helps sharing the knowledge between coworkers in the same team. What do you think about that?
So I'm not sure if I completely understand the question.
I mean that having competence probably for small teams is better than separating the team to different departments. It helps sharing the knowledge.
Yeah, so I think how I think about these things is that competence can be part of a team, right? Actually so what we did at Spotify, more so than I think at Datadog, because the teams are far more homogeneous into the requirements of skill. But at Spotify we had teams that, say we worked on radio, then you had, in the radio team there was front-end, back-end, data science, data engineering in one team together, basically being able to build a feature from A to Z. In other cases, you might have a team that's part of a larger organization that is specifically focused on, say, data science. It really, I would say, but being able to do that, being able to have different organizational structures, like putting all competence in a team that's part of an organization, or having a single person in a team performing or building a particular feature, is only, you can only do that if you see, say, data science or data engineering as a competence.